Well, hi, good morning. Thanks for joining me here in my shop. That's my backyard today. Everything's full of snow once again. We can take a look at my front yard here. That's the view out one of my front windows. You can see my bird feeder there. I don't think there's any birds on it at the moment, but there were birds on it moments ago. And look at all that snow out there again. So yeah, we were almost clear of snow, and this has happened. So, and more snow coming today. There's a look at a bird up there. Okay, so we ended yesterday's video with this radio apparently working well. So that's a great starting point. All that's really left to do now is to check the alignment, to correct it if it's off a bit. You can see I've written on the face of it some of the dial indications. So on the FM side, I've marked where 100 occurs, right where that dot is. And on the AM side, I've marked 1600, 600, and 1 million right in the middle. So when I'm aligning the radio, I know where it's tuned. I've also cleaned up, fixed up the cabinet. Cabinet was in great shape, so it looks pretty much brand new. Okay, so I think the alignment involves a number of different stages. I don't have alignment instructions, so I'm kind of winging it. So I think we'll start with the AM alignment because that's the easiest and most straightforward. And so I think we can start with making this observation. So when you look at the top of the tuning capacitor, this is a four section capacitor, and you can see 1, 2, 3 trimmers. The fourth one, there's no screw. There you are. You can see where the screw should be, but there isn't. So what's going on there? So there's another trimmer stuck way down here. So I'm guessing that is the local oscillator trimmer for FM, and this is the front end trimmer for tuning at the front end. Let's take a look at the schematic here. Okay, so on the AM side, even though we're looking at FM there, it's really the AM side, and let's just shrink this a wee bit. Oop, too much. Okay, have to leave it like that. Good. Oh, that's good actually. So here's the AM radio. Starts here with the AM antenna. As a tuner, this is the tuning capacitor and its trimmer working against this coil. And that coil, once it's peaked up, it'll have a very high Q on this coil. I don't remember seeing an antenna. Oh, it's a loop antenna right on the radio, Jim. I'm thinking a loop antenna on the back of it. No, it's a loop. Carbon rod loop type. Ferrite rod. Okay, so here we are. So this is where the energy actually gets into the radio circuit through this little secondary of the transformer. It's shot right into the base of this transistor. It then goes into this curious looking arrangement here, which I'm going to guess is some technique for mixing the local oscillator signal in. My problem here is I don't know where the local oscillator originates. Oh, wait a minute, what am I talking about? The local oscillator is going to be against this. So it's coming right in here. So this coil, this transformer and its coil must work against these capacitors to generate the local oscillator frequency, which is then somehow mixed in here through this circuitry I'm not that familiar with. So we could conceive that coming out of here is the 455 IF frequency, and then it's fed into the IF here. And we just take a quick look at the IF circuits. Right here you see these double diodes, and you see this pair of resistors in series, and this takeoff. You see a fairly large capacitor sticking out the end here. This is the detector for FM, and out of here, I think it's out of here. Somewhere out here comes the audio. So this is the FM coil. The AM IF, last IF coil is here. You see a single diode for the detector, very simple detector here. And onward the audio goes out here. It goes up into the switch that's selecting AM or FM and a light. So that's kind of where this is headed. You can see the IF transformers. There are two here and there are two here. One for FM, one for AM. And the IF signal, regardless of AM or FM, goes through both these coils every time. It only rings the appropriate coil, which then produces an output and the secondary carries on. Lots of radios built like this. The first time I saw this, I was surprised you could even do this. But you can. So you use the same IF transistors and amplifier circuitry basically for both AM and FM, even though the IF frequency is totally different. Okay, so somewhere in here there may be a AVC. Almost certainly there's an AVC voltage built up here somewhere. I don't know where. No, it would be out here after the detector. Of course I know where it is. It's out here. You might guess it's this. So I'm not exactly sure how you control the gain of a transistor. I'm just not sure. Can you just vary the base bias like a vacuum tube and you get a different gain? Not sure about that. It looks that way though. Looks like the DC that's built up right in here is shot down on this line through and up. Maybe they just control this one for automatic volume control. So the reason that's important is because that's an interesting place to take a test and monitor the output of the diode here as it rectifies the signal. It gives you an idea how strong the signal is. So I have to measure the strength of the signal coming out of the radio, either out of the speaker, which I think is what I'm going to do, or I have to pick off the AVC in here. I think I'm going to leave the AVC ID alone. We're just going to monitor the output on the speakers. Cover our ears if it gets loud. Okay, so that being the case then, we now know a local oscillator is one of the two trimmers up on the capacitor. One of the three trimmers, I guess I could say it that way, up on the tuning capacitor. And once that's set, then it's starts here with this transformer. Actually, you would start here with this transformer being tuned, and this one. Really, actually, take all that back. Leave the local oscillator out of the picture at the moment. We'll tune the IFs like any other radio. We'll just feed in an IF signal. Where can we feed it? Right in off the antenna here? Probably. Feed 455 right in off the antenna. Pump it through here. Monitor the speaker volume. Make the adjustments. I think I talked way too much for that. Way too much talk for that. So we'll be using this signal generator here. Okay, we're going to want this at 455. The output from here, let's get this one. This is the FM one, but just throw that aside for now. Put for there. Steal this. One of the things I'm looking forward to is trying to see that local oscillator on the SDR again. We'll get to that. See for sure it can be seen after I've got the local oscillator going in the FM side again. I never looked for it. 455, we could just bang it in on the antenna. Let's start with that. That's the easiest thing to do. You know what, maybe we're going to induce it onto the antenna. Hopefully that's going to ram some of the signal all the way through to where we need it. Where's my little... I have a silly little coil here somewhere. Okay, I have a bunch of silly little coils. Where are they? Here's one. Here's one right here. So we're just going to kind of hang that on there. This will be firing signal all over the place. Hopefully it'll sneak into the radio through the antenna coil here. If we get the signal coming out on the speaker, we're going to monitor it on this meter here. I'm going to use this one today. So this meter sometimes gives me headaches with inconsistent behavior, so if it starts doing that, we'll switch to another one. Put this on here. Okay. Put this on AM. And I want to be ready to make the change. Now it's going to be one of these two screws. I'm guessing one of these two. A local oscillator usually has less plates, but maybe not always. So we'll figure that out. Power off. FM antenna has not fallen into the outlet, which is good. We're set. Power on. AM. Excellent. So a good radio would be receiving stations right now, right through here. Now that's probably due to the signal generator. It's running at 450. So, you know, double 450 is 900. You'd think you'd hear it here, not way up here. You shouldn't really hear it at all, in fact. I'm watching the string in the pointer slider. No, it doesn't. I'd like to see if the string slides in the pointer. Okay. I'll set this right on 1,000,000. And we'll never mind the 455 for a minute, and we'll go and see if that's really 1,000,000. Get this back right here. Pretty close. You know, how close have I got this tuned really? That's good. Good. Okay, we'll pump in the local oscillator and see if that comes out. We should hear that all the time on here. When I get to that frequency, 455. Nothing. Oh. What's that doing right up there? Okay, not liking this. The radio's not likely to be that far out. It's not picking up anything on AM though. Is it? Maybe it is that far out. So one reason I'm hesitant is I'm thinking I'm not getting enough IF signal into the IF to do the tune-up. Or if I start tuning it, maybe it'll appear. I need to inject the signal a little more oomphy. Maybe I just move this coil to get more closely engaged there. Really expecting something at 455. There we are. Okay. I still don't think that's enough of a signal. If you want to actually inject one right into it, let's just move this coil around. Maybe there's a better... I'd like the radio to go kind of quiet. Trigger the AVC. There's not enough. Let's give it. Let's give it. Appears to be affecting the tuning a little bit here too. Okay. That sounds like a better tone there. Yeah, so I think the alignment is kind of messed up here quite a bit. I was doing some experiments the other night, looking at signals, and I won't get into all that. Just get to the point. The point is, in my house, there's a powerful noise signal at 450 kilohertz, just at the edge of the 455 kilohertz passband for an IF in every radio. It's just on the edge of it. And that's causing, I think, some effects when I'm doing the work in the shop here. I have this other signal sitting there, and you got signals right up against it. You're going to get heterodyne and other stuff, I think. So, something to keep in mind for me anyway. Discovered that using the SDR. Okay. So I think this is okay. We can at least go through it roughly and see what we get in the end. I mean, it's still not as I would like. You know, I could short the antenna out, all that kind of stuff, but why bother? Let's just try it with this. $455. Away we go. I gotta do this top and bottom too. That's right. I can't do anything with that. Okay, so I was picking which tool to use. Starting with the last. The last IF. We're watching the meter now. And listening. That's very bad. It's bad because no change happened. I'm thinking, oh my gosh, these much as I think they're the AM ones, maybe they're the FM ones. Let's twiddle one of the other ones. This is bingo. Okay, so we learned the hard way. It's up from underneath also? Maybe not. Oh, okay. Just let this fall off here. Okay, we're ready to go now. Not responsive on this last one. Oh yeah, right there. Back through. nicer sound down here. Let's try that. Okay, so we've aligned the IF, we've aligned it to 455. Next thing we want to do is look at the frequency of the local oscillator, and we'll do that using the SDR. Let me get it all set up here. Okay, so you can see the SDR obviously in the top right hand column. That blue, large blue bar in the middle there, in the middle up here, is the AM band. And the local oscillator in this radio will be operating hopefully 455 kilohertz above the dialed frequency. So let's find this out. I have my, this is the antenna for the SDR. This little coil on the end here. Nothing fancy here at all. Nothing fancy or special. So I'm thinking the local oscillator is probably easily picked up in this area. So I'm gonna stick this in here. And let's see, nothing obviously popping up. So I'll tune the radio and we can look for something moving around. Let's see, we're tuned around what, 700, so this would be 700, around 1200. So look for something moving. Oh, wait a minute, it's so small on the screen, isn't it? Let's try this. Okay, now look for it. Let's hear this. Oh, you know what? I'm blasting an IF signal into this radio right now. Let's get rid of that. Let's do that. There. Okay. I don't see it. So I'm looking for anything moving. Oh, there is something right around 1200 there. Okay, it's visible just below 1200. Let me see if I can find a better spot for it here. So this signal can be stronger, and I lost sight of it here. Okay, there it is. Well, maybe we'll just have to make do with that. I can't seem to get a stronger response anywhere else. So let's see. I will now, let's go back to the multi-display version here so you can see all the action. So I'm going to tune this to 600. Let's start at 600. 600. For some reason I heard my signal generator. Let's just get this out of here. I think I heard my signal generator. So we're at 600, 455 and 600 is 1055. So we should find the local oscillator running at 1055. And looking at that screen now. In fact, it's so small in my shot I can't see it. Here. There. Now I can see it. So 1055 is going to be right in this area. I bet you that, right under the green line, I bet you that's it right there. Let's see. Get this out of the way. I'll wiggle this back and forth a little bit. Yeah, there it is moving. So it's right above the U in the word medium, if you can see all that. Now, is that really 1055? Let me make sure I fooled around with this tuning. Let's just make sure it's right on the 600 mark. Okay, and we'll, this is the frequency right here. Just click on it there. And the frequency is 1053, and I had calculated it should be 1055. That's how close this is. That's really, really close. That's really good. Okay, so now we'll go to the other end of the band and we'll double check the frequency of the local oscillator up there. To 1600. 1600, so that'll be 455 on top of that is 2055. I'm going to move this to find it. 2055, would that be the top? Okay, so I'm going to wiggle the tuning again. there it is. I see a little, just to the left of the red line on my display. I go over under the red line, it's just to the right of it. It's lost in the next peak. Just coming out. What's going on here? I'm way past the 1600. That's what's happening. I go back to the 1600 mark. Right there. Okay, I see it. I see it. The little guy is right here. Get this right on. Okay. That's right on the money. The frequency is 2014. Now, wasn't this supposed to be 2055? It should be 455 kilohertz above 1600. Yeah. So what'll happen with this radio, when you have the dial set here, the radio will be tuning in just a little lower. Okay. So now we want to correct the local oscillator at this end, at the high end. The low end seems okay. The only adjustment I think is in here for the local oscillator is the adjustment on the top of the capacitor. So what we want to do is make the adjustment with this setting at 1600 until we see the little peak on the SDR end up at 2055. Let me mark 2055 here with the red line. That's right on top of that noise thing. Okay, now also we don't know for sure which screw it is on the top here. All the 1, 2, 3 screws. So the way we're going to find out is by interfering with the capacitor a little bit with my finger. So what I'm looking for is the local oscillator to shift. And I can't even see it. Where is it? I'm not looking in the right spot anymore. Okay, let's find it again. Oh my gosh. Anybody see that thing? Oh, this is falling here. Get this where we need it. Okay, I see it again. It's right above the letter A in the word ham. Oh, wait a minute, there's another one. Okay, so strange things happen on the SDR, and I'm never sure what to make of them. So the one I'm really after is the tall one that's drawing the snaky line down below. The reason we can see it now is I put the coil in a better spot yet than it was before. Okay, so tune the radio rate to 1600. It's pretty much where it is now. We can clearly see where the local oscillator is. Now I should be able to see the wiggle really easily as I touch plates or interfere with the capacitor. We should see it wiggle around. It hasn't moved the slightest bit, so I'll interfere by touching the plates with the capacitor. Well, you know, I got no explanation for why that isn't. You'd think with me touching the plates of the capacitor that would cause that local oscillator frequency to jump around. Am I looking at the right thing? Sure am. Okay, we're lined up again. Okay, well, I'll just try. So I think this one is the FM one, and since we're going to be fixing that later, I can monkey it up now. If I tune this, does it do anything? Oh my gosh, look at that. So now this is behaving like it's the AM oscillator. I got these maybe all mixed up. Well, well, okay. So this must, the other two must be FM. I got this all mixed around here. Does this affect anything? No. Okay, how about this one? Just touching it a little wee bit. So then what's that adjustment way down there? The only thing that's left is front end AM tuning. Okay, I don't know what's going to happen here. Make sure I can see the oscillator is, I believe I'm looking at it. Here we go. Play. Well, it's not moving the oscillator at all. I don't know what it's doing. Yeah. Okay, so I think we've concluded. We got to conclude. This is the oscillator adjustment. So now the objective is to get the oscillator up to the red line. Where'd it go? Oh, this thing's not even in there. Come on. Okay, let's to the red line with ye. It's on the red line now. 2055. So this radio should be properly tuned to 1600 at the moment. Go back down to the 600 and just see what's happened. Hopefully that didn't make any difference. There is no inductor to adjust, so it's kind of whatever it is, it is. Okay, we're on 600. So at 600 the local oscillator should be 1055, and it's 1058. We're not going to get any better than that. That's the difference between the width, you know, how accurately I put this dot on the front here. So that's perfect. That's beautiful. That's done. AM local oscillator adjusted to be linear across the band. So now we have the front end adjustment, which is probably that screw down there. So to do that, we will tune in a signal, let's say at a million, or even in the middle. Let's do it in the middle. I don't know that that's really the right spot, but we'll do it there. So we'll get the radio to receive something at 1 million. Again, I like a nice clean signal, not let me just make it a little video change here. Okay. Oh. It's a little better there. Just getting away from the noise a little bit. That's good. going to be a little loud in here, so I'll just turn down the shop mics a little bit. I'm going to go after that capacitor there and see if it's... So that capacitor is having no effect, and it sure seems to me that it's part of the FM circuitry. So hopefully when we do the FM side of this, that'll get corrected. So we have the IF, in the AM side we have the IF running at 455. We've got the local oscillator tuned properly so it's linear across the band and matches the dial settings. That's it for the AM. There's no... There is a front end trimmer, and it's got to be one of these two. This doesn't make a lot of sense. Maybe the pattern I'm expecting this capacitor to be used in isn't the pattern at all. Let's see if we can spot. There's still these two. Let's see if one of these will change the meter. Nope. Okay, son of a gun. Okay, so this is clearly the oscillator. I think. Let's just try that again. I got a little overwhelmed by the effect of that. Yeah, for sure. So what was that other thing I was turning? This is the front end tuning here. Oscillator tuning. Oh, I see now. So when I look at the capacitor, I made a big mistake here. I'm thinking AM, FM, or the other way around. I'm thinking front end oscillator, AM, AM, FM, FM. Turns out it's AM, AM, FM, FM. That actually makes more sense. The smaller plates, bigger plates together. Oscillator, front end AM. This is probably oscillator, front end FM. Okay, so now we know what we're doing, even though I was pretty happy with what I did before. Be a lot happier now. So back to the local oscillator adjustment. So we're on 1 million here. I'm going to make sure this is correct. We're on 1 million and we're putting in, oh my poor guy here, he's taking a break. There he goes. We're putting in 1 million signal. We're tuned to 1 million. We're hearing it. The local oscillator has to be correct. Sorry on the volume here. Okay, that's 1,000 on here, 1,000 going in. It can't get any better than that. And can we even see the local oscillator? I'm not even going to look for it at this point. That's good. Front end tuning now. Okay. Once again, it's going to get a little loud in here. Doing this at 1,000. Now, if you remember, this radio wasn't picking up anything. Let's see what it picks up now. Everything's normal? Yep. good job on the noise. Not too good. Let's see what we can do here. We're just going to wing it for a little bit. Hard to say. That's 600, 640. $590.
By the end of May or sometime next year. So I'd give him a shot, see what he's got, but I wouldn't be at all surprised if he ends up not providing much value. Yeah, I can't say I felt super great about it because of all the downsides that you mentioned. I felt like it was just a scenario that, hey, if this is a case where this guy can replicate it, I would like to jump on a little bit earlier and have that potential for a guy that can steal me 30 bags just because we know how scarce SPs are in
That's it. There we are. That's an AM radio online, I'm pretty sure. Not going to get any better than that. You know, this isn't the top quality radio. It doesn't have a great front end on it. So in the face of a lot of interfering signals, this one may not be able to select out the radio station so clearly. But not bad. I'm really not in a location where the AM stations are really powerful, where I am. So FM is next. Okay.